Hello, it's a pleasure to greet you. My name is Edgar Enrique Laramota and I am going to present you the next project that is entire production of better lactose from alpha lactose monohydrate for its pharmaceutical application. Let's start by talking about lactose, which is a disaccharide found mainly in mammalian milk, composed of a galactose and a glucose molecule bound by a glycosidic bond beta-1,4. Its most important properties are that it is a reducing sugar, therefore it has an intact carbonyl group that can react with other molecules. In addition, it partially has a free aldehyde group through which it forms a hemiacetal bond to build the cyclic structure. With the formation of the hemiacetal bond, isomers alpha and beta are produced. Lactose has different polymorphs: unstable hygroscopic alpha lactose, stable hygroscopic alpha lactose, beta lactose, and alpha lactose monohydrate. Of these polymorphs, the most important is beta lactose because of its different characteristics. This disaccharide exists in two isomeric forms, alpha lactose and beta lactose. Both show the phenomenon of neutral rotation, which is the interconversion of its stereocenters. Speaking of the uses of lactose, it is mainly used in the commercial additive food industry and in the pharmaceutical industry as an excipient. In this work, we will focus on its use as an excipient. The use of lactose as an excipient in the pharmaceutical area has been increased due to its properties: solubility, comparability, stability, bioavailability, and low cost. Excipients are a component of medicines. They are used to get a pharmaceutical formula. It's an inert substance with no pharmacological power. Lactose is the basis of more than 20% of prescription drugs. It helps the active substance function in a stable, effective, and safe manner. It is used in tablets for its solubility and pleasant taste. Currently, commercial lactose has been used as an excipient. In it there is a combination of two isomers, alpha lactose and beta lactose. One of the problems associated with its use is due to the stability of the molecule due to storage conditions. Justification: commercially lactose is a mixture of its different anomers. However, a number of studies has been developed that can lead to establishing methodologies to obtain pure anomers. Mainly beta lactose, which is less hygroscopic than anhydrous alpha lactose, which is favorable for its application as an excipient. Hypothesis: it is possible to perform the complete conversion of alpha lactose monohydrate to beta lactose by using methanolic solution of sodium hydroxide and potassium hydroxide, with and without reflux, as a means of conversion. Objectives: the general objective is to evaluate the effect of the use of methanolic solution of NaOH and KOH as a means of conversion, of the purity of beta lactose obtained from alpha lactose monohydrate. The specific objectives are to obtain beta lactose from the conversion of alpha lactose monohydrate using methanolic solution of NaOH and KOH. Determine the degree of purity by BRX and BSC of lactose obtained from conversion with the two methanolic solutions evaluated. Materials: alpha-lactose monohydrate brand sigma, HPLC grade methanol brand sigma, inorganic salts NaOH and KaOH reactive grade Fairmont brand. The conversion process was performed from the method described by Parrish et al. 1979. 5 different experiments were established, using 2 inorganic salts NaOH and KOH, resulting in 10 experiments, which were performed in triplicate for a total of 30 experiments. Methodology: for the conversion to better lactose using KOH and NaOH, the following experiments were proposed. In differential scanning calorimetry, the samples were analyzed in a DSC. The samples were subject to heat differential in hermetic aluminum cells. A thermogram was obtained by a hearing scanning of -90 to 250 degrees Celsius. Finally, analyze the results. In X-ray diffraction, the samples were analyzed on a diffractometer. An amorphous silicon zero background sample was used. CU radiation with a range of 5 to 90 degrees in 2 tera was used to finally determine crystallinity and degree of purity with software. For DSC, characteristic beta-lactose thermograms can be observed in experiments 1, 3, and 5, since they show a single endotherm around 230 degrees Celsius. In experiment 2, a characteristic thermogram of alpha-lactose was observed, showing 2 endotherms, one at 150 degrees Celsius and one around 200 degrees Celsius. As can be seen, the results coincide with those reported by Figura and Ebel in 1995. For DRX, as in DSC, you can see that the experiments 1, 3, and 5 show characteristic peaks for beta-lactose at 10, 19, and 21 degrees in 2 tera. For experiments 2, characteristic alpha-lactose diffractograms with peak at 13, 17, 19, 20, and 21 degrees in 2 tera. These results coincide with those reported by Kirk et al. 2007. It can be concluded that it was possible to carry out the conversion of the anomer alpha to beta-lactose. Identifying that an important factor for the change to be possible is temperature. It is important to continue research in order to be able to evaluate the stability of the samples obtained based on humidity and temperature, as they are factors that contribute to the change from beta to alpha.